The days are longer, the calendar's filling up, and I want to feel as good as this beautiful summer weather. That's why I've been loving Groons. It's one daily pack of gummies that covers my greens, vitamins, minerals, and even has 6 grams of prebiotic fiber, so I don't need to juggle a complicated wellness routine on top of everything else. They taste amazing. They're easy to toss in my bag on the go. Plus, they're vegan, gluten-free, and HSA FSA eligible for reimbursement. Save up to 52% off with code PODCAST at Gruns.co. That's code PODCAST at GRUNS.co.
Welcome to Cloud Coffee and Certs, the podcast where we chat about cloud certifications, learning cloud skills, and staying confident on the tech journey. Grab your coffee, relax, and let's level up together.
Hey everyone, welcome to another episode of Cloud Coffee and Certs. And in this week's episode, we will be continuing our AWS Load Balancer journey, which is really important if you are preparing for AWS Network Security Specialty Examination. We have already done a deep dive of AWS Load Balancer, so if you haven't checked that episode, I really suggest that you should check that episode because today is the last one on this topic, when we will be covering around configuration options for load balancers, especially target groups. We'll be also discussing about different configuration options for load balancer like cross-zone load balancing, session affinity, some discussion around Kubernetes cluster, how we can use AWS Load Balancer controller for managing our Kubernetes clusters. And last, we will be talking about encryption and authentication with load balancers, which will be specifically talking about TLS termination. So a lot of interesting topics coming through in today's episode. Also, I have some interesting news around cloud security because guess what? FIFA World Cup is going on, and it's not only in news because of all the interesting games which are happening in United States and other parts of Americas. It is also because of one of really interesting hack which actually happened in FIFA World Cup official streaming platforms. And good thing was the hacker was one of the good guy who really reported this sort of like gap in the security using which he can do like really bad stuff. But instead of taking leverage of that, the good guy, he just reported it to the right authorities, and FIFA and the right authorities, which in this case was, I think, US cybersecurity organization. They really took into consideration what was reported and they passed it. So we'll be discussing more about this in today's episode. Also, another interesting news, well, we've been featured, we as in this podcast have been featured as one of the top 30 cloud computing related podcast on the internet, and it's featured by FeedSpot, which is a website which deals with global media outlets and content creators. It makes them easy to discover and follow and contact different creators on the internet. And they created this list. I will post the link in the show notes as well. They created this list which you can follow as well. And in 30 best cloud computing podcast, one of them was us. So thank you all for those who are supporting me since 2022 when I started this journey. And although sometimes the episodes come hard and fast, sometimes there's a big gap, but it's all because of all the management which I have to do in background because I'm just a solo creator. I don't have any other support in the sense. So I truly appreciate with my heart with all the support which you guys are giving me in this journey. And I will, like I said, post the link in the show notes. You can check out some more interesting cloud related podcasts there as well, because I was checking the list and some of them are the one which I listen as well. So it's not like this list is having something which is you never heard of. I mean, it been featured with some of the best podcasts on cloud security and cloud computing, even by Cloud Security Podcast by Google, Cloudcast, which is I think one of the best one which I listened to, which actually made me thought of like giving this idea that I should be having my own podcast as well. So Cloudcast was number one, as I have anticipated. I mean, it's like I said, one of the best. And among all those lists, of course, one of them was mine as well. So do check that list out as well. And if you have, I think you can follow that website for other interesting contents as well. So, like I said, it was an amazing time. And in today's episode, we are covering some really interesting topics. So just stay tuned and let's get on with our news.
Let's hit pause on everything else for a moment and look at what's changing in the world of cloud and security lately.
All right, so welcome back, and let's talk about the World Cup. Now, specifically about how the entire global broadcast of the World Cup was for a little while, not like it wasn't really hacked, but for a little while, it was actually sitting on really thin line where it can go anywhere. Now, let me set the scene. It's June 2026. FIFA, the organization that runs the sports, is managing the biggest broadcasting events on the planet. Billion of viewers, I mean, a lot of camera angles, a lot of commentators, single feed worldwide, everything funneled through FIFA's system. I mean, when I was reading about broadcasting as a whole, now it's just a little bit off route from our actual news. I'm from India, and the news was that actually no one was ready to broadcast FIFA World Cup in India because of the high prices they were charging to all the broadcasters. Of course, they have like a certain cap which any broadcaster have to maintain, and which was really high for Indian broadcasters because India was not in the World Cup. So it of course for them it was like doesn't make sense to pay that much amount of money. And then that's when I realized the big amount which FIFA gets when someone gets this contract of streaming some services like FIFA official services in their country. Finally, FIFA World Cup is being streamed in India, so it's not like people in India are not able to watch. I'm not based in India, so of course I can watch in Sky Sports in UK, so that's fine. But anyhow, so there was a hacker. Back to our news now. There was a hacker going by the name Bob the Hacker who was looking all of that, just like me, and he actually got in. So I was not able to get in because I didn't even try. But he managed to get in, and not through like some elite 0-day vulnerabilities, or maybe trying to drop a USB drive where you have some of the parking lot in which FIFA officials were going on, and someone like take the USB drive and put it in their system. So it's not those like fancy ways of hacking an organization. Well, he signed up as a football agent. Now, if you are not aware of football agents, so these are like those men, or they can be women as well, to be honest, and it doesn't make any difference. So any person can be acting as football agent. What they have to do is just they have to negotiate transfers. They take maybe 10% or 15% of some, I don't know, 19-year-old who want to sign up for a club in Portugal or England. So anyone can apply for that because of course FIFA wants more and more agents to be on their platform. They want more and more talents to come up. So how you can register yourself as an agent on FIFA? Well, you upload your ID, verify your email, and that's it. FIFA will create a nice account for you on their Microsoft Entra system. Well, normal, it's cool, right? Well, except that this is the part that it should make every IT personnel like me spill up their coffee, because that agent account lives in the exact same tenant where you have FIFA's core internal systems. So the stuff that is actually running the actual tournament. So your user ID, your groups, your credentials, your all the authentication is going via the same Entra system where you have hosted your own servers where you are handling the whole streaming. So Mr. Bob the hacker, he pokes around, tries to access FIFA's core data platform, and of course, FIFA is a good organization, right? He gets hit with the access denied message. Well, great, he thinks security is working. But it isn't, because that access denied message was just, website being polite, like, hold on, you're not allowed. Can you stop doing this? But the backend, the actual server, which is supposed to act as like second guardian, that server didn't care. So once you get the key, so once you get past that initial front end website, you basically can go anywhere. So there is no second level authentication anywhere. So Bob described this as one of the most common pattern he see in companies that build some sort of like a beautiful front door, which will say like, you shall not pass, sign taped on it, but they just leave the back door just unlocked, which even with slight breeze, it just blows and open. So what did that get him? Of course, he was able to go into the live production hub for the entire World Cup broadcast. So he was able to see every camera feed, every stream, and not just viewing access. He was able to control it as well if he would have wanted. So he could have, I don't know, blacked out a match mid game. So just imagine you're watching your, I don't know, down with like 3 or 4 pints, you are cheering for your team, and then suddenly it's a blackout. Or worst, there is someone who is playing some other weird clip while you're watching that game. I don't know, it gets scarier, right? So this person can do actually anything during a live World Cup match. So billions of people tuning in, and then instead of like watching the game, they could have just listened to some song because this guy can do anything. So it's really getting crazy and scary now. Now, naturally, being a responsible human being and not a bad person to the society, he tries to report this to FIFA. And where it gets funnier now, FIFA actually have no contact for security. So there is no sort of like vulnerability disclosure policy, there is no bug bounty, nothing. So they think themselves like we are the big guy, we are the big shots, we decide like who gets to play where the football, we gets to decide who gets to pay us like millions of dollars for broadcasting our this streaming, but we don't care if someone wants to report a security incident in our website. So that's really scary, right? They don't have anything. So he was not able to get hold of anyone in FIFA, and that's what he does next. He calls CISA, he calls the FBI, because apparently that was genuinely the most functional part to get a message to the visa to FIFA. So you should go via actual United States federal government, because FIFA's own front desk, I don't think they care, like. And so, well, to the FIFA's credit, of course, because they are a big organization and they finally realized this big bug, they fixed it, and it was pretty fast as well. Like within next day, they fixed everything and they involved all the agencies. And by now, by end of it, it was a great outcome. We haven't seen any funny video playing in midstream of broadcast anywhere. We haven't seen any news about it in like in our day-to-day news as well. So that's a good thing. It's still in the security pages only. So it haven't actually jumped from security news to official primetime news bulletin, because FIFA finally patched it and now everything is fine. But moral of the story, next time someone tells you that their system is secure because they have like access denied page, ask them, well, is that a real lock or is just a funny, or not funny, but a serious sign? But that's it. There's nothing behind. Like there's no concrete backend control secure path as well. So you have to make sure that you have defense in that. And I think that really put us in a good segue for our topic of the day, which is securing our network, because securing network is one of the most commonly left out layer of defense in that, but we also have to take care of that. So that's it. I mean, that's the news. It kind of get interesting that because like all of other people who may be listening to this episode, I'm also following the World Cup pretty nicely. And moment I realized that something like this has happened, I thought that, man, I want to share this news with all of you guys. So that's it for today's news. And after this short break, let's go with our main episode.
Let's level up, refill coffees, and dive into the main episode.
All right, welcome back. So let's continue our load balancers journey. And today we are talking about configuration options of load balancers. So start with what's cross-zone load balancing, what is session affinity, routing algorithms, which we have in AWS Load Balancer. Now, when people first start learning AWS Load Balancer, I think the focus usually on the basics, which is distributing the traffic, or I don't know, improving the availability, scale your applications. But by now, in various episodes, I also tell it repeatedly many times that you have to move beyond that. You have to see the real power of the load balancer. They have a lot of use cases beside these, the simple ones. So in this episode, let's talk about some of the important load balancer configuration options, which actually help us in achieving these advanced use cases. So first of all is cross-zone load balancing. Now, if your application is deployed across multiple availability zones, so for example, if you're EC2 is running in, you have two EC2s and they are running in availability zone within the same region, different availability zone within the same region. But without cross-zone load balancing enabled, your load balancer node only sends traffic to targets within its own availability zone. So that sort of can create some sort of uneven traffic distribution. But if you enable this load balancing, cross-zone load balancing, you have option of distributing the traffic evenly across all the healthy targets in all enabled zones. So it is really helpful when you want your infrastructure to be properly balanced in terms of traffic going through both EC2 instances almost on sort of like a same load. And if your one availability zone is temporarily have maybe fewer load, or maybe it's down because of some event, or it's in maintenance, then cross-zone load balancing will make sure that this load is distributed to other zones instances as well. So it will make sure that utilization is always under control. So it's of course really important when you're creating a highly critical application which don't require even a single, which can't afford even a single seconds of downtime. For example, maybe your banking application, your transactions should also always go in the real time, and you don't want, because of utilization, your application going down. So for application load balancer, this is enabled by default. For network load balancer, you have option to turn it off or on. So of course, it's one of those things which you have to make sure you keep in mind while configuring those. There is a trade-off though, because when you're talking about cross-zone traffic, AWS charges. So if you are an architect, then you have to make sure that you take into consideration those bits as well. But I think it's a nice trade-off, because if your application needs it, then there's no brainer, right? You have to enable this feature. Let's talk about sticky sessions now, also known as session affinity. Now, when your load balancer distribute your request independently, a user might hit one server for their request and a different server for the next one. But it's totally fine in today's modern architecture. I mean, most of application, they are created in this way these days, that they can handle the same request. So there is always continuous sync between those applications happening in backend. But not every application does that, especially if you're putting something from like rehosting some application from on-prem, and it's just lift and shift. So maybe your application is not fully stateless. So in those case, your backend server, if your user is connected to a specific server, maybe they want to keep connecting to that server for their whole session. Otherwise, it might not be as synced as they want, and they might lose something in between. So for example, if your application is for e-commerce, and someone have put they have filled their cart with some items which they want to buy, and next time the user hits to a different target, and because it's a new session for that target, all their shopping cart is empty. So of course it will really drive them crazy, right? So that's where sticky session comes in, because sticky session, it enables your user is always connected to the same server. So it sort of stick your user session to a particular backend server. And it's of course it may lead to a traffic distribution which can be uneven, because of course you might have a scenario where 20 or 30 or I don't know, hundreds or 200 users, because of sticky session, they are always forced to be connected to a specific backend server. But of course, that's again, you have to take in consideration, and you have to make sure that you have some sort of like better sync happening between the backend servers. So it's again some sort of trade-off which you have to take in consideration, but it's really a good feature to take use of when you're creating your application and you're planning for that. Another interesting configuration option is proxy protocol, which is really important when we are using network load balancer. Now, if you remember, network load balancer operates at layer 4. So this means that it forwards traffic without modifying headers like your application load balancer would. That's excellent for performance, but sometimes backend applications still need some sort of visibility into original client IP address. So that's where proxy protocol comes in, which adds a small header into your client connection information. This allows backend server to see the original source IP and destination IP. Now, this is something which happened to me in one of the project which I was doing in a day job, where I have to put network load balancer in front of my applications which are in different spoke VPCs. Now, the load balancer was then connected to a peer network via transit gateway. And on the peer network, transit gateway and the security groups were only allowing my network load balancer IPs. So of course, one of the option was that I could have enabled this option, and I could have told them like, can you allow the traffic for everyone? So giving the whole spoke VPC IP addresses as well. So in that case, it would have made sure that my requests, which are then going via this network load balancer, and the transit gateway and the application on the peer side would be able to see my source IPs as well, the spoke VPC's IPs. And with this option enabled, they would have seen the whole IP range. But because I haven't enabled this option, all they were seeing in all the requests was only my network load balancer IP. Now, in this particular design scenario, it actually helped me because I disabled this option. All they have to do on the peer end was allow my network load balancer IP. And because the source IPs were encrypted inside the header, my traffic was going through. Otherwise, if I would have enabled this option, they would have seen the traffic coming from the source IP address, and they have to write like whole set of security groups. So of course, like everything else, this is again a design consideration, what you want to achieve. And if you have this use case, you have this scenario, then you can go for it. I mean, this is absolutely fine. Let's talk about some of the routing algorithm, because ultimately load balancer are distributing the traffic, right? Now, how they should distribute the traffic. Classically, all the load balancer primarily used to use round robin, so they used to go like randomly distributed sequentially across healthy instances. Application load balancers are more advanced. They can do intelligent request routing based on content. So they can maybe route your traffic based on URL, hostname, HTTP header, IP conditions. So it helps specifically in the microservices where you want, for example, slash API to go a particular endpoint, you want slash home to go to another endpoint. So all those sort of like advanced routing scenarios you can cover using application load balancer. Network load balancer are pretty basic in terms of what sort of routing algorithm they use. So they normally use flow hash algorithm, which considers source IP, destination IP, or you can use ports and protocol as well. So it's another way of achieving your random, or not random actually, distributing the traffic across different endpoints or different targets. Now when we are talking about targets, let's talk about target groups, and we have different configuration options for target groups as well. So what are target groups? Well, they are the targets, or they are the set of instances, maybe EC2 instances, which are sitting behind load balancer and which are expecting traffic from the load balancer. So AWS support multiple type of target types. One of the most common type, which I just now mentioned, is instance mode, where you just forward the traffic to EC2 instances, which are registered in the target group. So this is sort of like a traditional VM based workloads. But of course, modern architecture often use different other ways as well. So one of the way is using IP as the target mode. So with IP targets, traffic can be routed to specific IP addresses instead of the EC2 instances. So your EC2 instance ID will not be registered as a target, but IP address or ENIs will be registered as target. So it is really powerful, especially if you have ECS or Kubernetes, because then you can send the traffic based on the IPs of pods or containers instead of sending it to your worker node IPs. So this is really incredible, and we will of course touch base on the Kubernetes, how EKS cluster and load balances come into picture, but that's something we'll cover in the end of episode. Now, beside IP addresses, we can use TCP target groups as well, which is most commonly used for network load balancer, where you can decide a port based traffic forwarding as well. So you can use TCP target groups using network load balancer, and we have a specific protocol which is Geneve. I don't know whether you call it a protocol, but it's another sort of route. I think it should be called as routing algorithm, or maybe I don't know. So this protocol or this routing algorithm is specifically used in AWS gateway load balancer. Now if you don't remember, gateway load balancer is a specific kind of load balancer which is used in virtual network firewall appliances, or IDS or IPS system, or deep packet inspection tools. If you are putting those third party tools on your cloud, and you want traffic from your different VPCs or different hosts to go via these firewalls, then you can put them behind this gateway load balancer. And for that specific traffic between gateway load balancer and your security appliances, we use Geneve, which is acting as an encapsulation protocol. So in simpler term, it allows AWS to transparently steer traffic through these inspection devices without applications even knowing that it's happening. So if your end system, your EC2, you're still sending traffic outside via your net gateway or whatnot, but there is actually some sort of inspection happening in the middle which your application will not know. So it's really amazing use case if you're having sort of hub spoke architecture, where on the hub you can put this gateway load balancer and your firewalls, and you can use this Geneva protocol to make sure the traffic is going between these gateway load balancer and the security appliances. Now let's talk about load balancer for Kubernetes cluster, because of course when you're talking about modern cloud infrastructure, how can you leave Kubernetes? It's one of the things which is sort of your biggest weapon if you want to claim like you're cloud native and you know a lot of things about cloud. You have to of course put some sort of like information on Kubernetes. Otherwise people will think like, what are you talking about if you don't know Kubernetes? Well, that's where Kubernetes cluster comes in. AWS Load Balancer Controller. Now, AWS Load Balancer Controller is the integration which help in creating load balancer based on your requirement on your Kubernetes cluster. So how it works? If you have worked with Kubernetes before, you know that Kubernetes itself can expose application using services and ingress controllers. But in case of Kubernetes on AWS, there is AWS Load Balancer Controller, which will help you create these load balancing services based on your port or your application requirements. So instead of manually creating application load balancer or network load balancer in AWS, you can define what sort of desired configuration you want inside your Kubernetes manifest. And once you run that manifest, your application will automatically spin up a load balancer using this AWS load balancer controller. So controller will be running in your kube system namespace. It will be responsible for understanding the requirement, what sort of ingress or egress you want, what sort of target groups you want to your application, what sort of routing rules you want. So everything you will put in that manifest, and based on that requirement, plus load balancer controller will spin up a load balancer for you. You can of course choose you want ALB or NLB, but of course based on your requirement, it will spin up what you need. So that's why it's really amazing. I mean, it's really easy to manage your application, put your application, your pods in running on EKS cluster behind application load balancer or network load balancer based on your use case. So application load balancer controller, sorry, AWS load balancer controller is the service which you really want your EKS cluster to have. Otherwise, of course, you have to create your own load balancer every time. Now, remember when we talked about target groups using instance mode and IP mode? That's in the Kubernetes. I think IP target mode is one of the feature which is really valuable, because without IP node, load balancer will be just sending the traffic to your worker node, which you don't want, because that's extra network hop, right? So traffic will go to from your load balancer will be going to your instance IP, and then it will be going via internal container routing before reaching the pod. Instead of that, you can do IP target mode, in which the load balancer can send the traffic directly to your Kubernetes port. So your pod, your application will be getting the traffic directly from the load balancer. So that's why it's again the same scenario, where based on your use case, you can decide and design what requirement you have. So using AWS Load Balancer Controller, you can have this amazing containerized platform which is running on EKS, and which of course have a sort of like cloud native connection between your application to the outside world. This controller also have advanced AWS security and networking features enabled as well, because we had talked before as well. You have various other integration with load balancer. You can have WAF protection for your load balancers. You can attach your certificates for TLS termination. If you are using internet facing application or internal load balancer, you can have different configuration options based on your requirement. So that's why it's a completely no-brainer that you always run your application with load balancers on EKS cluster. So that's one of the design consideration which anyone who wants to make sure that their application is more cloud native and they are running with security, they can have this AWS load balancer controller on their EKS cluster. Another key thing when you're running Kubernetes resources on AWS infrastructure is IAM permissions. The controller needs IAM permission to create, modify, and delete AWS load balancers, because you're running a service in your EKS cluster which can create load balancer based on requirement. So of course it need to have some sort of permissions on your AWS console itself, right? So that's where we use something called which is IAM rules for service account, or IRSA, which in common term is just a mechanism to grant permission to the controller. Using this service account and the role attached to this service account, controller can dynamically scale the load balancer target. It can create new resources, and that's how it does all this fancy interesting stuff without even human intervention. So that's why AWS load balancer controller highlights some sort of like a broader industry shift where people are now moving towards more easily moving towards creating, instead of monolith application, they are moving towards EKS based workloads. So that's the integration of load balancer with Kubernetes, which I really want to touch upon because it's really interesting. I'm using it in my various labs and other projects as well, and it's really amazing service to use. Now, before we end today's episode, let's quickly touch the last topic of load balancer, and finally we can say goodbye to load balancers, especially for AWS network specialty, which is consideration around encryption and authentication for load balancer. So examples like TLS termination and pass-through. So let's cover this subtopic as well. Now, encryption and authentication, this is more, seems like a security kind of topic. But of course, when we are talking about AWS advanced networking, we have to think from all perspectives. So not only we have to solve the networking problems, we have to make sure that when you're solving the networking problems, we are making sure that we are secured as well. So that's where we want to use encryption and authentication in our load balancers. Now, load balancer have this way of handling TLS connections. So they can have certificates, they can also enable user authentication. One of the most common approach is TLS termination, where we terminate our HTTPS connection from the client end on the load balancer itself. So on the load balancer decrypts the traffic, inspect what is needed for that traffic, and then forwards to the backend target. You can encrypt it again, or you can keep it unencrypted if it's inside a private trusted network. So it depends on what sort of use case you have. And of course, this is very common pattern in terms of application load balancer. If you want to don't manage your own certificates, you can of course perform the integration with AWS Certificate Manager, which can automatically provision and renew the certificates so you don't have operational overheads. It also enables layer 7 features because application load balancer can now inspect the HTTP headers and content after decryption. So you can perform more advanced path-based or host-based routing based on the requirements or based on where this traffic should head to. Now, I did mention that you can actually enable the re-encryption as well. So in this model, after the traffic is decrypted, inspection and routing is decided, traffic is encrypted again before sending to backend target. So it will make your end-to-end traffic flow completely encrypted and of course more secure. It just increases more operational complexity, and this again comes back to your decision what sort of architecture you want. And as a network architect, you have to decide what you want to achieve as an end goal, because if you're sending encrypted traffic back to backend servers, then backend servers have to have some sort of mechanism to decrypt the traffic again, and that of course increases their operational overhead as well. Another key thing is TLS pass through, which allow that traffic just pass through without decrypting at all, and it just forwards the traffic in encrypted format. And this is, from the name itself, sounds like something network load balancer will do because it operates on layer 4. So in this case, backend server will handle the TLS negotiation and certificate management. Biggest advantage here is it's end-to-end encrypted. So you don't have to decrypt and encrypt again. The traffic will always be encrypted. There will not be any plain text content. So if you are having highly sensitive workloads, then of course you can use TLS pass-through. Of course, there's a trade-off because you are losing layer 7 intelligence, and you are of course losing advanced routing functionality, which normally comes with the application load balancer. Again, this is something as a network architect, you have to decide what sort of architecture you want. Now, I did mention about authentication, which is another powerful capability. Instead of application implementing its own authentication workflow, you can make sure that load balancer can integrate with identity providers, and then it can handle authentication on the load balancer itself, so before even reaching the traffic reaching the backend application. So for example, you can make sure that your application load balancer is integrated to, I don't know, Entra ID, and then it simplifies the authentication logic because now it moves closer to your infrastructure layer. So all these advanced features like TLS pass through, TLS termination, and authentication, they can help make sure that your load balancer are not just traffic distribution tools, they are having security and identity control points, what you need in modern cloud architecture. And that's what we want. That's we want if as a network architect we want to create a secure design with all the advanced features, we have to make sure that we know all about the load balancers and what sort of capabilities they have. Well, that's all about this week's episode, and we have covered the load balancers. So now we can move to our next topic, which is around defining logging and monitoring requirements across AWS and hybrid networks. So in this topic, which we'll be covering next time, we'll be talking about CloudWatch metrics, we'll be talking about transit gateway, network manager in the architecture, VPC reachability analyzers, how we can use flow logs, traffic mirroring, and access logging. I don't think it's a big topic, and I'll try to cover it in a single episode, and from then on we will be going towards routing strategies and hybrid networking. So it's getting really interesting now, and of course we will be saying goodbye to our domain one soon. So that's all for this week's episode, and like I always say, goodbye and good luck.
Been listening to Cloud, Coffee and Certs. Thanks for tuning in. Don't forget to follow and share if you enjoyed this episode. Until next time, keep learning and keep growing.